Hey, today we're going to talk about another special right triangle, but some warm up beforehand. We're going to solve for the variable in each one of these equations.
Today's lesson, our first lesson, is about one type of special right triangle, the 45, 45,
y
90,
equals 5 half square root 3 or 2.5 square root 3.
We're asked to do a couple
Your
of
y would
warm-ups.
be
This is
12
an old
divided by the
technique
square root
that
of
we
3.
talked about last
We need to
semester,
rationalize like we did yesterday.
That means removing
and we'll end up
the
getting that
irrational
y is really 4
number from
square
the
root
denominator. And what we do is we
the second part
multiply
of the
by that
warm-up
same irrational or
asks us to
that same
determine
square root
if we could use Pythagorean
so
theorem, and
that
if
we
can,
have a square root of a
to
perfect
indicate
square.
y. And so in this triangle, I would say yes, because A equals B.
And our
And
irrational component moves to the
isosceles
numerator
right
instead
triangle.
of staying in the denominator.
Go over to this
We do
one.
this because the definition of a rational number is a number that can be expressed as a ratio of
yes,
two integers. And we know
y
that an irrational number is not an integer.
Right. Try.
Oh, I don't even have to do that here.
Because
I notice anything divided by itself is just 1.
I don't
so this
have an
simplifies
isosceles right
so
triangle.
be on the lookout. You may not have to
I have a
multiply
scalene triangle. I'm
to
going to say
rationalize the
no.
denominator. Here we're going to use the Pythagorean theorem, which we practiced yesterday. So we take the two sides that make the right angle and we square them. Now, some of you seem to have been really upset by the fact that we have irrational numbers as side lengths. Should not. We've been talking about irrational numbers for a long time. This means I have 2 square roots of 2. 2 square roots of 2. It's a perfectly fine real number, and we need to know how to deal with it.
2 out of the 3 sides.
If you use your calculator to evaluate this, you need to put it in parentheses so it squares the entire base of 2 square root 2. I'm going to write it by hand since I cannot work a calculator and this program at the same time.
Triangle. And again, we could apply
but the things that look like each other next to each other.
Variables to find and only
look like
one
each other
equation to
next to each other.
Connect those 2 variables. All right, so if we analyze how we answered our questions above there, A and B, we know that the other acute angle is 45 degrees, and we know this because acute angles of right triangles are complementary.
A squared is 16. That means A is equal to 4.
That is, their measures add to 90 degrees.
Cut out some of the steps
These
for this
triangles
one
are
since
called
I did all the steps in the last problem.
Right triangles. These are the ones we studied yesterday because exactly
2 squared is 4. Square root
we are able
6
to use the
is
45.
2 squared is
90
4. Square root of 3 squared is 3.
The Pythagorean
so I have a 24 and a 12
to calculate missing side lengths. However, in triangles C and D, the measure of the other acute angle is 30 degrees. Again, because the acute,
recall, the
angles
square root of
right
x squared is the
complementary.
absolute value of x.
These triangles are
But
not
writing that
triangles.
here in this case because I
E
know
and
I
D
need to
are
get positive
scalene
values because I am
triangles
looking
because all
for
3
a
angle
value
measures
of
are
x
unique.
that
That
could
is,
be the
equal.
side
However,
length
these
of a
2
triangle.
are special right triangles.
All right, if we look at these 2 right triangles, they are special, and a name that I could give them would be
the sides.
Isosceles.
And I measure
all
right
3
triangles.
Isosceles because they have exactly 2 congruent sides.
all 3 sides. And now we need to get out our
sides, protractors, and do some measuring.
Millimeters.
Here we have a triangular shaped stamp, and we need to measure.
This is not a right triangle.
All 3 angles inside of the triangle. So
if we look at our measurements,
for doing that,
both the angles and
the
sides
mark off the angle
the
to give yourself a reference so that you read
to each other. So
the
the
measurement, the numbers on the protractor correctly.
Lateral
and then I also need to measure my side lengths here.
Triangle. And again, if it's one, it's got to be the other.
I measured from tip to tip. So
how far this angle opens
serrated
and
pieces were my outside border. If you wanted to measure
okay, so we're going to move on to the one below it. Easier. You want to use your protractor and draw an altitude from the
not the angle
top
measurements,
angle
but the side
to
measurements.
the base. And we have to recall that an altitude is a segment
why
from a
the
vertex
measurements of the angles of the enlarged stamp are the same as those of
to the opposite
original
side.
Stamp.
So what you want to do is you want to measure 35 millimeters.
And
this is going to be a perpendicular and a bisector. You're going to use your straight edge to draw in that segment. And you're going to measure to make sure that you got a 90-degree angle. And that way we know we have an altitude.
And we know in
then it asks the
question,
if we look at this
congruent corresponding angles.
Equilateral triangle that we started with,
what am I noticing here about
could we also classify this as an isosceles?
And
I would say yes.
I would make, you may observe something else,
it has
that I have
the two congruent sides. It has more than two, but the minimum requirement for an isosceles is that 2 out of 3. And then it says recall the altitude of the isosceles triangle bisects the base. So we had 70, but now I have 35 on one side and 35 on the other. And the altitude also bisects the angle. So let's go ahead and measure to make sure that that happened. We're going to measure the two acute angles.
That leads me
and when we do that, I get 30 degrees.
My next conclusion here to fill in the blanks, I already said it above.
So it did bisect the 60.
The triangular stamp is
30.
Right.
And I measure my altitude here.
And isosceles.
And I'm just going to write it off to the side so I can see it. My altitude is about 62 millimeters, 61, 62.
Two very special things about that triangle.
And what we notice here is that the altitude of an equilateral triangle produces two 45 triangles.
90.
Now, if we go back in the Wayback Machine here,
of the hypotenuse,
and think about what we did last unit. Last unit, we started with a right triangle and put in an altitude, and we got similar triangles.
This is good news for us.
Today we start not with a right triangle, but with an equilateral triangle. Put in an altitude, and we end up with a missing side length. We can just apply this theorem. Each triangle has here's an example. We have an isosceles right triangle. The two legs have to have identical measurements, and to get the length of the hypotenuse and multiply the side length by this factor square root.
So
2.
A 30, 60, 90 triangle,
if we go back to our stamp, is formed from an equilateral triangle. Or you could write,
and I look at the length of one of my legs,
analyze what's happening here. With the 30, 60, 90
and I multiply that by the square root of 2,
we can look at our hypotenuse of that triangle. 5,
didn't have a hypotenuse,
and that's really close to our measurement of
95
right triangle.
And again, we can have measurement
error.
The length of this hypotenuse is,
but I'm believing what they're telling me,
times the length of the shorter leg.
So if we want to prove this theorem, we can go ahead and use the Pythagorean theorem to do that.
We have a squared plus another.
This one's a little bit more difficult to see.
The shorter leg times the square root of 3.
If we were to combine like terms,
35
we have
times
2
a
squareds.
Now we need to solve for c. So we would take the square root just as you were doing yesterday,
and that's pretty
close.
I would have to the length of 2 times the absolute value of a equals the absolute value of c. Again, we don't need to use the absolute value here because we're talking about a positive value for A.
And we are not able to
C
use
because we're making a triangle talking about the length of a side of a triangle.
30, 60,
so
90
C is the square root of 2A,
which is what
so it says the length of the hypotenuse in a 30,
so
60, 90 triangle is always twice the length of
so to
the
summarize,
side,
for an isosceles right
and
triangle,
the longer
45,
leg
90 triangle,
triangle,
the two methods
the
to
60
find
degrees
is
always
again
the
length
shorter
of the
side times the square root of 3.
The
So these problems I say
45,
are to get
90 triangle theorem.
Shorty is what we want to do.
And apply the
Shorty.
Pythagorean.
He's the shortest side.
Theorem. So you could go either way.
As long as we get Shorty, then we can use that, just like we used the sides to find the hypotenuse yesterday,
and use
the hypotenuse to find the sides. Here, because we have to find three sides,
look at another
triangular
sides.
We have a little bit more work than we did yesterday.
The longest side. So
okay, so if we go back to our Malaysian stamps
that we measured,
so we're back to our 70, 70,
these angles are congruent.
62
that
millimeters.
Means the sides
opposite are congruent.
So this
step
is
the measure of the shortest leg was 35. The length of the longer
or you
leg
could have written
is
45
times the square root of 3, would end up being 60.6.
And
our
our
measurement of our longer leg,
theorem
at least
to
what I got,
determine
was
the
62.
approximate side lengths.
Fairly close.
So those are
the length of the hypotenuse.
It's very similar to what we
is
just
again
did. We have
that
x
35, the shorter
plus
leg
x
squared
times
2
equals 50
which gives
squared.
us our 70,
our B,
and what
and our
we
C.
did measure
I have
was
2x squared equals.
So again, like yesterday, we proved for
I would
the
take the
one
square
case
root,
that we
I'm gonna
measured
divide
that
both
it did
sides by
work.
2.
Now we're going to
Smart.
get
So
generic
x squared
and prove it for
1,250.
let's think about proving
So
it for
an
other
x
cases.
Is the square
So
root
here,
of
like the one yesterday,
which
they
is
are giving us information. We do not need to measure. They're saying,
millimeters. And I
this
can measure
is
that
an
to confirm.
equilateral
Now I'm going to take the
triangle,
shortcut.
which
The
means
shortcut
all side lengths
has a
are
relationship
equivalent.
that the hypotenuse is the side length times the square root of 2. And I'm going to solve for
and we are
x,
going
or
to
my
go
side
ahead
length.
and
So I
determine
would
the
take
height of the stamp,
50,
which is really the length of an
divided by the
altitude that I
square
would
root of
draw
2.
in. And so it's helpful to go ahead and draw this in.
Again,
and now
I get
what
that
we've
x
got
equals
is
35,
30,
4,
60, 90 triangles. And we know that this,
and we verify hopefully with what we just did here, our classmates, that the values are
of the original triangle side.
equivalent.
So now that we
or
have
the
that
same.
information, we can
Or
use,
equal.
like we did yesterday in our exit slip.
Okay,
the
so how we're going to
Pythagorean
apply
theorem
this
to
is
solve
we're going
for
to find
h. So I have
missing side
h
lengths
squared
of isosceles
plus
right
20
triangles.
squared.
So if you're
equals
given the
40
leg length,
squared.
that's obviously
H squared
what the
is
other leg equals.
100
Because it's
minus
isosceles. So I would do that one
400.
first.
H
And then to
is
go
the
from a
square
leg
root of
to the
1200,
hypotenuse, you take the length of the
and
leg
that's approximately
times the square root of 2.
34.6 millimeters. Now if we use the 30, 60, 90
And this is
triangle
the problem
theorem
we did
to
in the warm-up
determine that
using
side length, we
Pythagorean
should get to
theorem.
34.6.
45,
says
45, 90.
that
These two sides are
the
congruent,
height
so right away I just say I have
is
3
going to be
halves
the
of the square root of
shortest
2
side
is
times
the
the
value
square
of
root
y.
of 3.
Then to get the
This is
hypotenuse,
short
I
side
take
across
3
from the small
square root of
angle.
2
the
over
longer
2
side across
times the
from
square
the
root of
larger
2,
angle,
using
and
that
of course the
45,
hypotenuse
45,
across from the right angle.
90 theorem.
So that
And I
means
get that this equals 3.
H is the 34.6
This one's different. Now I'm given the
millimeters, and let's even
hypotenuse.
just try out
So
finding
rather
the
than multiplying by the
hypotenuse
square
here,
root
if that
of
works, and it does
2,
because
I
20
need to divide by the
times
square root of
gives us
2
40
to get the side length.
So both
And this is
pieces
where I need to do that
prove out.
rationalizing.
And
So now I'm going to multiply
when we look
both
at
the numerator
our
and denominator by the
calculations
square root of 2.
from the two methods, like yesterday, we noticed that
And
they
this will
are
give me 3
equivalent.
square roots of 2. And that's measure of both sides. These are
So
really not a lot of work
30,
at all.
60, 90
And I'm
triangles
given
here.
the hypotenuse, so I'm
bit
going
more
to be
work than yesterday
dividing, not
because again we need to
multiplying by
find
the
2
square
of the
root of
3
2.
missing sides.
So I have x
But we
is
always
2
want to
square
go
roots
and
6
find
divided by
shorty
square
or
root 2.
get
Now
shorty.
here I don't necessarily need to worry about rationalizing
first.
because there's a common factor.
If
in
we
each
have the
of
shortest
each one.
side, then life
6
is
and
easy.
2, so I'm going to
The
put them
shortest side
underneath
length
the
here is
same
2 because
radical
it's across from the
and
30-degree
simplify
angle.
that way.
To get you the
You
hypotenuse,
can rationalize
you
it
would
if you want. You will
take
get the same
2 the
correct
side
answer.
length times
Hey, again, we can put this
2 because
in
that's what the formula says. To get
context here
4,
to solve some word
and then again
problems.
to get
The first
B,
one's done
we're
for
gonna
us. It says that
reference
Emily is
short
building
side
a square
times the square root of
bookshelf. So
3,
we sketch a square,
and we
and
would
she
get
wants to add a
2 square
diagonal
root
support.
3,
A diagonal
or if we
connects two
wanted our
vertices that aren't already
decimal
connected.
The diagonal divides the bookshelf into two 45, 45, 90 triangles. It says if each side of the bookshelf is 4 feet, what must the length of this diagonal be? So you can approach this two ways. You can very quickly get your answer using the 45, 45, 90 triangle theorem and multiplying a side length by the square root of 2. Or you can go through the process of using the Pythagorean theorem and solving for x, and you will get very much like this one. We have the short side. I can see clearly here which one has less steps. It's across from the 45-degree angle, 90 triangle theorem. So now to get u, the hypotenuse, now we have to try one on our own times that prospect part 16 is a square. Like the Emily sketch, the longer side or the middle side, we take again with side length of 5, but we multiply it by the square root of 3. One of the paths through the park runs diagonally, talking about provide our decimal approximation, east and west, from the northeast corner to the look at this picture here. We do not have the shortest side. It's missing. But we have to find that first. The park it's always about getting 45, 45, 90 triangles. Which would be this one right here. How long is to find shorty? So you can use the 45, like yesterday. 45, 90 if we had shorty, we would multiply by 2 to get the hypotenuse. So today, to go back and get shorty, we need to take the hypotenuse and divide by 2. The relationship does not change. They're related by a factor of 2. Theorem. Here we have the double, so we have to take half of it to get back to the original. Equals and now once we have shorty, then we've got the side is shorty times the square root. Take the square root. The 512 comes out here. Square root 2 stays inside, so x is again equal to 700. Again, we do not have shorty, but we want to get shorty. The path. So we look at what we have. We have the hypotenuse. So we're essentially solving the equation. The length of this hypotenuse is 2 times shorty. 724 meters. So the length of the shorter leg is 8 square root 5 divided by 2, which should be 4 square root 5. So y equals 4 square root 5. The last little bit and is now we would take that complete. And multiply. You need to determine the height of the isosceles triangle, and then you need that to find the area of the entire triangle. 15. The area of the triangle is 1/2 the base times the height. Is about 15.5. So a quick summary on what we just did on this page. If you have the length of the shortest side, shorty, to calculate the longer side length and the hypotenuse, you will use the mathematical operation of multiplication. However, if you are given the length of the hypotenuse, you need to first calculate the length of the shortest side, so shorty, by using the mathematical operation of division. Okay, very much like yesterday. Right, one more case we have to consider is, again, we do not have the shorter side here. This is shorty. We need to get shorty. And so essentially, again, we're thinking about if we had shorty, we'd multiply by the square root of 3 to get this longer side. So we need to divide by the square root of 3 to get shorty. And once we have shorty, then we would multiply shorty by 2 to get the length of our hypotenuse. And we look here, we do not have shorty, but we need to get shorty. So we look to see what we have. We have that middle side length, which is always the shorty times the square root of 3. So we are solving this equation, which has us divide by the square root of 3. This, like we did in our warm-up, leaves us with 4 square root 3. Now to get the hypotenuse, we take double that to get 8 square root 3. Done that one before. This is approximately 13.9, and 4 square root 3 is 6.9. Okay, so for each of the problems that follow here, we need to draw a picture first, label it, and then we can come up with, analyze the picture, come up with some sort of formula, substitute in the formula, solve for what we need to know. So here we said find the area of an equilateral triangle with side lengths of 15. So we draw an equilateral triangle. To find the area, I need to use the formula 1/2 base times height. So I need this height. When I put in that altitude, that's going to bisect this side using the Pythagorean theorem or the 30, 60, 90 theorem. I get the length of my height is shorty times the square root of 3. I substitute in this formula and I get 97.4 square meters. So it says now we have these pennants in the shape of 30, 60, 90 triangles. So let's draw a 30, 60, 90 triangle. That means a scalene triangle. The 30 degrees is across from the shorter side. 60 is across from the longer side. And it says the length of the longest side of the pennant is 16. Now to get my area, I have to take 1/2 this base times this height. So I need to find the other two sides. I need to get shorty. So to get shorty, I need to take 16 and divide it by 2 to get 8. And then to get this middle length side, I take shorty times the square root of 3. And then now I do the math. And I get 32 square root 3. And if I put in my approximate answer, I get approximately 55.4 square inches. Remember, area is inches squared feet per unit.